Okay, I want to move on to questions 3 and 4 from quiz 4. And let's move over to my iPad. I'm wanting to hit the idea of differentiating and anti-differentiating, you know, integrating, finding the integral, the difference between differentiating and anti-differentiating is really important. This question number 3 starts with differentiate this number, this term, this binomial. And so there were more than one of you raised this, you took the antiderivative of it. Notice that the wording, you've got to get the wording down. It says to differentiate 2x cubed plus x squared. It's vital that you remember that that's going down. You know what I mean? That's the idea of you drop the power by 1. The differentiate means it's going down in contrast to the antiderivative going up. So differentiating, the first step of this is raise the power by 1. No, it's so bring the power down front and subtract the power by 1. So what do we have? Bring the 3 down, multiply it times the 2. We have, that means if this is y, then we're going to y prime equals 6x squared plus 2x. And notice that how familiar that looks to the next part of the question. The circumstance is that this was part A, and then part B is coming back and saying, integrate, use the fundamental theorem of calculus to integrate 6x squared plus 2x. And recognize the relationship dx. And recognize the relationship between these two expressions. And that's what we're working with here. So that means it should take us back up to y, that other term up top. So what we'll do here now is we're going to take the antiderivative using the fundamental theorem of calculus. And remember, a key part of it is that you've got to remember that the indefinite integral is what we're talking about so far. But in the way the problem is set up, I do put a 0 and a 1, making it a definite integral. But if it's going from A to B, the integral of lowercase f of x dx is equal to, now the integral of lowercase f means it's taking it up to the antiderivative. And you take the antiderivative at B and subtract the antiderivative at A. That is using the fundamental theorem of calculus, part 2. All right, so what we've got to do is take it back up, and that's where we just came from, right up here. That is the antiderivative that we're going to be looking for. But anyway, let's do this now. So I've got the 6 out front. I raise the power by 1 and divide by that new power, plus 2x raise the power by 1 and divide by that new power. Yeah. And that ends up giving us, and that we're going to take the remainder of the bar, the integration bar, so to speak, of what A and B are. And going from there. So the circumstance is now we got to plug 1 in and then plug 0 in and subtract. Notice this also, that both terms are just, their x is a factor. And as a result, when you plug 0 in, the whole term is going to be 0. So that's something to pay attention to. Sometimes it will and sometimes it won't. Sometimes it'll, plugging 0 in doesn't make the term 0, but in this case it does. So let's plug in 1. 6 times 1 cubed over 3 plus 2. You know what? Pardon me. Let's simplify this first, right? Simplify this. So what we've got here is 2x to the third plus x squared, and that's being taken to 0, from 0 to 1. Okay? So let's hit that again, from 0 to 1. All right. And notice that is the antiderivative that we had started with there. from 0 to 1. And now we will plug in 0 and 1 into this reduced, these reduced terms. So we end up with now equal signs throughout. You guys remember your equal signs now. Let's just plug it in. Plug in 1 into the entire function. Okay, and there's f of b minus f of a is I'm going to plug 0 in. And again, if you recognize they're both going to be zeros, you could stop and do 0 right now. But I'm going to go ahead and remind us that this is 0 plus 0, right? So that is what we're going to end up with. That's going to end up being 2 times 1, which is 2, plus 1, minus 0, which is 3. And then it is a matter of checking out that you take the antiderivative and plug in your plug it into your calculator and verify the circumstance. And it'll be it will be obviously 3. Make sure you check your work. Anytime you have a definite integral, that you check your solution on the calculator. All right. So that is the answer for number 3. Let's go to a different screen. Let me start over for question number 4. That's got a little bit of a different contour to it. These are indefinite integrals. 4a is the indefinite integral pi. Notice, and it's important to pay attention to the terms that are involved when you've got this. Recognize, is there an x there on that first term? No, that's a constant. Know what you've got to do there. Don't be distracted by it. And then the second one is second term is a power, x to a power. So let's do this now. So there's nothing to simplify at all in this. All we need to do is take the antiderivative, and remember, this is an indefinite integral. There's no a and there's no b. As a result, that means you're going to need a plus c on this problem. All right, so we've got a constant, so I'll put a note up here. Plus c is something I need to remember. All right, so the integral bar is going to go away. That's a constant, so that becomes pi x. And then we're going to the next term, we raise the power by 1 and divide by that new power. And then we get the plus c. And if you notice, this is pretty much the final answer. There's no simplifying. That is it. Okay? Take the derivative and make sure you get the original term back. You know? Take the derivative of the first term and you get pi. The second term, you bring the 10 down. 10s cancel. You got x to the 9th plus 0. Got it. All right, that's fairly straightforward. And let's look at 4b now. This is a definite integral. And there was a 2 there to start with, wasn't there? 2 e to the x dx. Okay, so this situation is one we've got to find the antiderivative of 2e to the x, and our a and our b are there, so the answer, since this is a definite integral, the answer should be a number. The answer should be an actual value. So let's take a look at what we're going to do here. The antiderivative of 2e to the x. We get the 2, and the antiderivative of e to the x is? Yes, e to the x. And that's it. And we're going to take it from 0 to 1. So now we just are going to be plugging the numbers in. We end up with 2e to the 1 minus 2e to the 0. Some of you left it there in this format for your simplified exact answer. And that e to the 1, that can be simplified. That 1's not needed up there. And that e to the 0 is 1. So this can be simplified down to 2e minus 2. And there were a handful of you that went ahead and factored this out. I think it was out of the habit from when we're dealing with x's. But if you notice, those are all numbers. There's no variable. Like if you were trying to say when is this equal to 0, that's great, but that's not what you've got here. So this is a fine answer right there. That is an exact answer. Notice it's still got an e in it. There were several of you, probably about 5 of you, who tried to write out a real long decimal, as many as you could, to make it as exact as possible. And that's not what exact means. Exact means it's still got the E in it. It's got pi in it. It's got this number that is an infinite decimal that you don't plug into your calculator. It's still E. It's the square root of 2. You know, those type things are stay in there, and if you, as soon as you plug it into your calculator, it becomes a decimal. It is no longer exact. You've got to round it. This one right here, you don't round. So that's the exact answer. And then if you plug it into your calculator, I get 2e second division bar, and that gives me 5.4356. Yeah. And let me write that out just as a reminder. This 2e right here is 5.436563. I said to round it to 4 decimal places, so I'm making sure I go past 4. And then we got to subtract 2 from it. Okay. So that means it's just going to be 3.436563, yada, yada. I said round it to 4 places. Some of you rounded it to 2 places. I'm not sure what triggered that. Writing it out, that's one danger of writing on a separate piece of paper. You didn't see the rule that I was asking you, what I wanted you to round it to. It said 4 places. So I've got to go out to the 4th place, look at the next digit. That is 5 or above, therefore I've got to round up. So my answer is 3.4366. Okay? So this is my answer rounded to 4 decimal places. This is my exact answer. 2e minus 2. Okay? So I will ask you to do that on the test on Wednesday also. Give a exact and give a rounded. Make sure you've got this down. Okay? And with that, I think we're going to go on and be ready to handle this type of a question, the indefinite integral and the definite integral. Distinguish them. And always you can check this on your calculator. You know, you could, it's a definite integral, so you could check it on your calculator. Okay, thank you, and practice this. If you want to review it, you can feel free to do so.